In summer, we require ice in our beverages, at least we like that. And in the winter, we rely on ice to protect aquatic plants and animals. So let's learn more about pond ice from some experts. I'd like for you to welcome to the stage Dr. Robert McClellan, who started a citizen science organization called Rink Watch, along with fellow scientist Dr. John Rosales, a climate change scientist focused on the impacts of climate change on native peoples in the Arctic. Now, threaded through his work is a call to align human institutions within natural limits by challenging monocultures of the mind or fossilized ways of thinking that overwhelm the planet. Come on up. So here, there we go. Give my hand. All right. Let's welcome next Dr. Brendan Wiltsey, is a senior research scientist with Paul Smith College and the Adirondack Watershed Institute, also known as AWI. At AWI, he leads the Water Quality Monitoring and Inventory Program and oversees the research on conservation of freshwater and ecosystems. How are you? All righty, welcome. We also have Kate Glenn from Paul Smith College. I need to introduce you as well. And she is the Sustainability Coordinator and an instructor in the Department of Environment and Society. All right.
Wonderful. Thank you very much.
You're welcome.
Hi, everybody. Good afternoon. Thanks for taking the time on this very sunny day to come and sit with us when we talk about outdoor ice. As stated, my name is Kate Glenn. I'm from Paul Smith College. I'm the college's Sustainability Coordinator. If you would like to learn more about sustainability at Paul Smith College, just paulsmith.edu/sustainability. You can hear about all of our great initiatives. So I'm really thrilled today because I get to share the stage with three regional researchers and academics who are studying outdoor ice from various perspectives in our region. So all three of our researchers are going to give you an overview of their research. We do have some slides, so they can just go ahead and say next slide when they're ready for the next one to come up. And then we'll have about 30 minutes at the end of our session for question and answer. We'll also talk about some common themes related to citizen science, climate change, sort of the future of athletics when we see climate impacts on science and, and ice in our region. So there's some things that we're going to be doing for the next hour. So how many of you have ever been ice skating? Yes? Excellent. That's pretty common here, right? It's one of the things we look forward to in the winter. How about playing some pond hockey? Anybody done some pond hockey, right? Okay. And, I was sort of thinking about when they asked me to moderate this session, I haven't really done much ice skating or played much pond hockey, but I have done a lot of ice climbing in my younger days. Anybody here up for ice climbing? Oh, I see a couple of hands. I'm not alone, right? Yes, excellent. So those are one of the areas, when I started ice climbing, the quality of that ice was very important as you were hanging on that rope, and that's something I've always really connected to. I know that here in the Adirondack region, I've lived here for 15 years, ice in and ice out on our lakes. You go down to your local bar and place your bet for when the ice out's going to happen. It's certainly a part of our sort of culture and life up here, so I'm really excited to sort of explore this topic from many perspectives. So enough from me. Let's get started. Brendan Wiltsey is actually going to start us off today, and then we'll hear from Robert and then John. Excellent.
Great. Mic working?
Might have to click it. You want to use mine? Just use mine.
Go wired rather than wireless. So can we maybe try changing the slide? We'll see if my slide made it into the deck. Yes. Okay, cool. So I am a limnologist, which is a fancy way of saying I study lakes for a living. And one component of that is climate change. Another component that we work on at the Adirondack Watershed Institute is road salt, and I want to just give a shout out to Orta. I don't think Mike is in the room anymore, but he mentioned recycling energy to reduce the amount of salt put in front of their facilities. And I recognize sometimes the irony that perhaps climate change is going to result in less road salt, so I feel the tension there occasionally in my work. But in the sphere of studying how lakes are responding to climate change, one of the most powerful records we have is that of the ice cover on our lakes. And in many cases, these records date back many decades and also many centuries. And so it's, I think, important for us to think about the fact that the people that started recording this did not do it because they were climate scientists. They didn't do it because they were scientists at all, and in many cases they weren't doing it because they were expecting to track some long-term change in the environment. In most cases, those ice records were kept for very practical reasons. Kate mentioned probably one of the most classic ones, which is people were celebrating the end of winter. They actually wanted winter to end, or were looking forward to it ending, and so they would put a bet on when the ice was going to go out on their regional lake. And because money was on the table, people started keeping track of those dates so that hopefully next year your bet maybe was a little bit better, and your chances of winning that pot of money went up a little bit. But there are a lot of other reasons why people have kept track of ice on lakes. Some very practical, like if you were an ice harvester. Think back to the days, definitely before my time, where that was the way we kept our goods refrigerated. If you were one of those businesses, you probably wanted to keep track of when your local lake was freezing and thawing because your business depended on it. And in other parts of the world, our lakes are conduits for transportation in the summer, and when the lakes are not frozen, that's by boat, but also then you needed to wait until the ice was formed on the lake so that you could start moving across their surface again, and so those records were kept for those reasons as well. And then there's also religious reasons. One of the longest ice records in the world is from Lake Suwa in Japan. It's an astonishing 580 years of record keeping on that lake for religious purposes. The local monastery or community associated with that lake has strong religious beliefs and ceremonies tied to the formation and even change of the ice on that lake, and therefore have been recording those for 580 years, and they're still doing it today. Locally here, we heard earlier, if you're in the session with Dr. Kurt Steger, we go back to the early 1800s for Lake Champlain, which is just to the east of us. We're in the headwaters of its watershed, and I happen to be wearing the Lake Champlain ice record right now. My colleague at AWI, Dr. McKaylee Glennon, has a project called Woolen Water, where she is working with citizens to knit environmental data into fiber arts projects. And so this scarf, every row is a year in that record, and the blue color where my hand is years that the Lake Champlain completely froze, and the lighter blue and the darker blue are years when it did not freeze. And we have the early 1800s over here, and we have present day on the right, and it doesn't take a scientist or much skill at all to notice that this scarf is different on one end versus the other. Thank you for helping to hold that up. Behind me on the slide, we have the record from Mirror Lake right here in Lake Placid, which dates back to 1903. And it's the bottom sort of right corner of this slide, shows the duration of ice cover on Mirror Lake over that period of time. And again, you don't need to be a limnologist or a climate scientist to look at this figure and see the trend that's occurring on that lake. It's on average 3 weeks less ice cover today than there was in the early 1900s. And I think that's a huge amount of time and a huge amount of change over that period of time. And if you look on the far right, you'll see one dot way down at the bottom. That was 2015. And I remember that year in particular because it was the first year that Mirror Lake did not freeze until January. And the whole way that we as scientists had been tracking and entering that into our database, that actually screwed us up considerably because we were moving from one calendar year into another, crossing that threshold. And I remember, okay, how do I deal with this in our data set now in terms of running the statistics and everything on it? So we've seen this big decline in ice on Mirror Lake over the last 130 years. Around the figure here, I put some pictures from a camera that the Ausable River Association installed on the Golden Arrow Lakeside Resort. to help capture and document this ice record. And these photos, to me, exemplify sort of both our relationship with lakes here in the Adirondacks, as well as how that is going to change in the future. So in the top left is a fairly typical weekend here in Lake Placid out on Mirror Lake. You'll notice there's people swimming in the lake, using hydro bikes, paddling, canoeing, fishing, doing all the things that we think of when we think about recreating on a water body in the summertime. And on the top right is what it looks like in the wintertime. This happens to be, I might cherry-picked my images a little bit, but this is the Can-Am Pond Hockey Tournament, which I think is going to be relevant to some of my panelists later on as they speak. But in the wintertime, you go out on Mirror Lake, unfortunately not right now, but typically it would be a flurry of activity. There's ice skating rinks in front of every hotel. The village maintains a skating path around the lake, and there are people out there enjoying that. And other lakes in the region, I would argue some of them are actually utilized more in the wintertime than they are the summer. Just down the road near my house is Lake Colby. And in the wintertime, there are more people out there ice fishing than you ever see on that lake in the summer, paddling or doing any of those other things. The bottom left picture is what Mirror Lake looks like on a late November or early December day, even on the weekend. I don't think you can see anyone out on the lake that time of year. The water temperatures are dangerously cold. It's just not a time of year that you want to be out on liquid water. You really would rather be out on some solid ice. And this is essentially the trade-off that we're making in what the future of our lakes are going to look like here in the Adirondacks in the winter. We're going to have less of the upper right and more of the bottom left. Hopefully I got my right and left correct. So that's really what we're looking at here in the Adirondacks in the future. And I'm not going to touch so much on the competitive sports, but I'd remind folks that there are a lot of other sports that are not associated with, these types of games that mean a lot to the people in this region and other parts of the world, particularly ice fishing, snowmobiling, cross-country skiing, sort of from a recreational purpose. And one of the big outstanding questions that we have at the Adirondack Watershed Institute is not only sort of keeping these records going, but also thinking about the thickness of the ice on our lakes and ponds, not just the duration of ice cover, because that has important ecological implications in terms of how our lake ecosystems are going to change in response to a warming climate. But I think of the people that are out on those lakes that maybe don't understand or fully sort of internalize the fact that their winter sport and recreational activity is probably going to become a lot more dangerous in the future because they're going to be ice fishing and snowmobiling on thinner and thinner ice, and the conditions in which the ice is dangerous are going to occupy a larger portion of the winter time in the future. And there's some evidence to support that that's already happening on lakes, here in the Adirondacks and around North America. So I guess I'll just leave it with that, and I will pass it off.
So our next presenter, Robert here, will be speaking about his research, and I believe you can access, actually, if you go to the descriptor for this session, there's a website where you can actually see a lot of the data that he's been gathering, and it'll be an interesting thing to do. You're allowed to use your phone, so it's okay, we won't take it personally. We'll assume you're looking up his program and data.
Great. Thank you, Kate. Thank you all for coming. I guess you're not interested in the Buffalo Bills game, or else you're watching it on your phone right now. If anybody has a score, please shout it out for us. Okay, good stuff. Thank you. Yeah, so my research is on how climate change causes large-scale displacements of people around the world, things like floods, droughts, and storms, and I serve on the Intergovernmental Panel on Climate Change to do research on that. And just over 10 years ago, a fellow environmental scientist and I were trying to figure out how do we make people who are sitting in the drive-through line at Dunkin' Donuts care about climate change and its impacts? When, for very good reasons, they have busy lives, they've got kids, they've got amateur sports and so on. How do we explain to them that the climate is changing? So I'm a Canadian, and there's two things Canadians love to talk about in general, the weather and hockey, right? So we deliberately sat down and said, how can we create a science outreach project that brings those two things together to explain climate change? So we created Rink Watch. Maybe we can put the first slide up there. There we go. So it's a website. And in January 2013, we put it out there in the world and said, if you have an outdoor skating rink in your backyard or that you maintain one in your neighborhood park, visit our website, pin its location on our interactive map, and then just use this really simple drop-down menu to let us know what the skating conditions are like on a daily basis. And you can see on the little round button on the right-hand side there, there's a little map there, and all those little black dots are locations of rinks that over the last decade have provided information about skating conditions. So about 1,500 or so, more than that now I think, over the course of the last decade. Now some of those, I don't know if you've been involved in citizen science in the past, but sometimes you get people who try it out, they do it for a week and then they abandon it, and then you have other folks who do it religiously every winter for the last decade. Both are good. Because what we can do is we have literally thousands of points of data that say on this date, at this location, you could or could not skate. And so then what we did is we created a program to take that data and compare each point to the nearest weather station data for the same day. And now we have, we can identify the critical temperature threshold to identify what makes a rink skateable or not skateable. So we know that water freezes at 32 degrees Fahrenheit, 0 degrees Celsius, but actually it needs to be colder than that to have a hard skatable surface. So the magic number is really about -5 degrees Celsius or low 20s Fahrenheit. So now that we know what that critical temperature threshold is, now we can go back through historical weather records and recreate past skating seasons for which we don't have data, and we can use climate models to cast forward to see what outdoor skating conditions will look like in coming decades. And we've done exactly that, and we've published these data in scientific journals. Have I got another slide, I think? Can we go one more slide? There we go. So on the left-hand side, what you see there is a map of the 1990s from one particular set of climate data. And all the areas that are shaded blue are areas where in the 1990s you could confidently say people could build outdoor skating rinks in their backyard in most winters. Now we recognize it varies from one winter to next, and you get freeze-thaw events and so on. But you know, these are the areas where the average January temperature, daily temperature, is -5 degrees Celsius or colder. So that's what you see on the left-hand side in the 1990s, and you can see very clearly the Great Lakes represented there, which means that upstate New York falls within that shaded area. Now, if we go over to the right-hand side, you see that you can see Lake Superior and the west coast of Lake Michigan, but the rest of the Great Lakes disappear. Essentially, that -5 degrees Celsius territory is moving northwards, and that will be in the 2080s, and that's not a worst-case scenario. That's the current case scenario. This is, for the scientists in the room, this is an RCP 4.5 scenario, which means this is what we're currently locked into. So we're not talking about the apocalyptic scenario. This is just what's going to happen. Almost at this point, unavoidable. So what does this mean in practical terms? We had a graduate student interview participants in our program to find out, why do you build an outdoor skating rink in the first place? I don't know if you've ever done it, but it's insane. It's a really silly thing to do. You have to spend night after night standing out in the dark with a hose in freezing temperatures. Or it's a Zen thing, depending on how you approach it. So the question becomes, why would you do this when you could be inside watching hockey on TV? And the answer is that people do it not because they think that their kid is going to be the next Haley Wickenheiser or Wayne Gretzky or Pat LaFontaine for a good New York State skater. It's because they want to build a place for their kids and their neighbors' kids to go play in the dark days of January instead of them being cooped up in the basement playing hockey on their video games. That's essentially why they do it. It's a neighborhood meeting place, and they get great cultural and social value out of it. So in the greater scheme of things, we're going to lose a lot because of climate change. Last year, there was about 25 million people around the world displaced from their homes because of floods, droughts, and storms, and so on. And that number is going to keep going up in coming decades. So in the comparison with that, the loss of the opportunity to skate in your backyard seems kind of trivial, doesn't it? But at the same time, it's what makes people from the northern parts of North America who they are. There's a saying in French, mon pays c'est l'hiver, my country is winter, right? And so we lose that. So we'll still be around, and we'll have conditions like what we had earlier this week, where you have to wear a raincoat instead of a winter parka and so on. So that's what we're losing. And as was pointed out by Natalie in the previous session, which is in the worst case scenario where we do nothing about climate change, things get much worse for the ski industry, for the skating, the recreational opportunities, for the resort communities that depend upon those incomes for livelihoods, and of course, the bigger picture as well. So anyhow, that's what we do at Rinkwatch, rinkwatch.org. If you have a rink, if you want to participate or have a look at some of the science we do. Thank you.
Our last presenter, John from St. Lawrence University, is going to talk a bit more on our related topic, looking a lot also at hockey also from that perspective. So feel free to check out that descriptor for some more information.
Well, this is great to sit next to Robert, especially because what I just handed him was our last publication, which was looking at this particular thing that he just mentioned. And it started out with the same impulse. How do we make climate change itch? If it created a rash on your skin, we'd probably do something about it. Or if it questions your personhood, if it causes you to be nauseous, if it had a direct impact on your body and maybe even your identity, then perhaps we would do something about it. So I talked to my students about that back in about 2017, and we decided to have a research seminar looking at the impact of climate change on expertise, on producing expert athletes in hockey, in skiing, Nordic, and downhill. So we held that in 2018, and we gathered some data in that research seminar, and it came out with this publication here that I just handed to Robert. If anybody wants a copy, we have them back there. So if you could change the slide, please. I brought a couple pictures as well.
Uh-oh, technical difficulties, folks. Just give it a minute, maybe. Okay. Blackout.
Okay, so I'll explain it. So yeah, we did want to somehow expose this idea of making climate change itch. So the picture I wanted to show you was of our pathetic backyard rink. We actually signed up for your organization back in 2019. But a week ago, my son Jacob, who's right in the middle of the room back there, he's a hockey player, 16-year-old varsity player. We've been trying feverishly to have a backyard rink this year, but it's just not working. So it was a picture of
this is not a good year for that.
It is not a good year.
No.
It wasn't a good year last year. It's just hard. It is a lot of work, so I can relate to that. But we studied in the research seminar, we were wondering, how could athletes get the number of hours needed to become experts? And if we could make the case that with climate change, North Country athletes simply won't be able to log in the hours to become expert hockey players, and Canada would have an advantage because you're a little bit further north, as you just saw.
Get personal here.
Yeah. So we did that. At the same time, we read Malcolm Gladwell's book, Outliers, and we found out reading that book that he bases a lot of his argument on a researcher from Florida State called Erickson, who just died a couple years ago. But Erickson looked at this idea of expertise and how long it takes people to get to that expert level, whether it's being a musician, mathematics, games, or athletics. And he never said that you need to log in at 10,000 hours at anything and you'll become an expert, because there is some variability. 4'2" person will not play in the NBA, for example, even with 10,000 hours of practice. But we used that as a budget, and then we went to our own Hockey Association, Canton Minor Hockey, and I was able to get all the practice time available to them through our own association. And the team that logged in the most practice time were the travel girls team. And it has a lot to do with the aggressiveness of the coaches who pick up extra ice time. But they logged in 3,000 hours between the ages of 3 and 18. Wow. So over that time period in our fairly rigorous hockey association, an athlete could get about 3,000 hours out of perhaps the 10,000 that they would want. So you have to do other things if you want to be an expert athlete. You have to get out on your driveway. You have to play floorball. You have to play down in your basement or on your backyard rink. And that was our argument. Could they log in the 7,000 hours extra that they would need with climate change? The other thing I wanted to show you is that we also used general circulation model projections for 2050 and for 2100. And under the high emission scenario, there would be no more ice in Canton, no way to make the backyard ice rinks in Canton. I also ran it just last week for Mirror Lake, same scenario. And even under some conditions, under 2 degrees warming for Mirror Lake, it's going to be very hard to maintain backyard ice because you need it for 3, 4, 5 days before you even decide to start, and then you need it to maintain itself. So that was our project, and we found that it's going to be very difficult. Luckily, in Canton, though, there might be the possibility to still have backyard ice rink if we meet our Paris Agreement goals, especially if it's 1.5 degrees. So that's the other graph I wanted to show you, is that it's a very steep graph that we have to now descend to get our emissions down to net zero by 2050 and then go negative. And that oftentimes is forgotten. We need negative emissions in the second half of this century. So we really need to do things fast. That's why I was pressing the other panelists in the last session, where are you at? And I was really glad to hear Vail Industries is shooting for 2030. That was surprising and a good thing. So what I wanted to show you is where we're actually at, because many of you know under the Paris Agreement, countries of the world have to submit nationally determined contributions, these NDCs, where they show their hand. They make a commitment to X amount of cuts by certain dates. And we're well short of being on that 1.5 degree slide down that we need to be on. So we need to double down. We really need, all hands on deck to reach that. There's one last thing that I wanted to mention as well, and that is in those scenarios of getting to net zero by 2050, they do not include positive feedbacks. And there's some major ones that we have to be aware of. I am an Arctic climate change scientist, not really an Adirondack one. I'm here because of this little article here, but I study the Arctic. And permafrost is probably Arctic permafrost is probably the most sensitive positive feedback that we need to keep our eyes on. The best science is telling us that at 1.5 degree warming, we may pass a threshold where there is no return. And that is that the permafrost may start melting and positive feedbacks kick in and we can't stop it. You may have just heard that we're at about 1.3 degrees warming so far, so we're very close to the 1.5 degrees already. El Nino is coming back. El Nino dumps a lot of extra heat into the atmosphere. So over the next 2 years, we are probably going to go over 1.5 degrees warming. So we are at the threshold right now for the Arctic permafrost. The Amazon is another one that we need to look at, and certainly the big methane stores in the ocean, methyl hydrates, but those aren't as sensitive as the Arctic. So with that, I'll open it up or give it back to you, Kate.
Sure, wonderful. Thank you so much for that
I
information.
don't know if that was wonderful, but
No, it was good. I think, one of the things that I think has been really obvious in all three of these sort of research studies is this citizen science and engagement sort of piece, right? And you've done a lovely job of tying in the importance of the science. If some of these are new concepts for you, I encourage you to maybe do a little research on your own on things like positive feedback loops, El Nino, La Nina, and these impacts. These are important aspects of our climate and will really help you sort of understand and interpret some more of this. So it's wonderful. It was good to hear that sort of link. So just getting back to this idea again of citizen science, I wonder if the three of you could talk a little bit more about that engagement piece. And obviously, there was a motivation here, but people definitely seem to have really responded and engaged in this sort of research that you're doing. So if you could talk a little bit more about that, that would be great. Do you want to start us off, Brendan?
Yeah, I think the ice records are sort of inadvertent citizen science over the years, and there are efforts around the world. People that are interested in lake ice are starting to come together to try and organize some of this data. There's a lot of variation in what you think. It's simple, like what is ice on, what is ice off. It's actually defined almost differently for every water body. But one of the things that we're starting to look at the Adirondack Watershed Institute is that the last piece I mentioned, the thickness of ice, is something that's hard for us to it's not hard to measure. You go out and drill a hole in the ice, but we don't have a lot of those measurements on inland water bodies, especially smaller ones. And so we're starting to engage with particularly the sort of ice fishing and snowmobiling communities, which I think in general we've heard a lot about winter sport athletes being ambassadors for climate change, but I think that's a whole segment of the winter sports community that we haven't really engaged enough with, and probably have some of the just as much to lose with the loss of winter as anyone else. And so we're hoping to build up this network of people that are already out there poking holes in lakes for various reasons. Most of them are fishing through those holes to report some of that data so that we can get a better understanding of that ice thickness. And again, the safety aspect, I think, is most important for human communities, but there's a whole set of ecological implications if the ice becomes thinner, or even the quality of the ice that's being formed on our lakes is changing as well.
Yeah, just picking up from that, then I guess in terms of citizen science, when we talk about climate change in the Arctic, for example, we talk about in the mass media, the general discussion, disappearing polar bear populations, we talk about glaciers disappearing and so on. But the reality is that most Americans and Canadians will never encounter a polar bear, have never seen a glacier up close. And so they understand that something's happening, but there's no personal connection. But when you take it to something like a backyard skating rink, A, they can say, oh, okay, I understand that. And B, I can observe that, and I want to, this gives me a chance to participate in the conversation. And one of the things, picking up on your point there, was that the National Hockey League got really enthusiastic about our project a few years ago because they worry about the future of hockey because hockey's an expensive sport. League fees, arena fees, equipment fees, and so on. It's becoming an upper middle class sport. And how do you get kids to learn about hockey? You don't want to dump $2,000 into equipment and league fees for a 5-year-old who's never skated before. They need a backyard skating rink or a pond and a pair of skates to just try it out and get enthusiasm for the sport. Just like mom and pop ski hills are the entry point to elite skiing. There has to be a neighborhood ski hill that they can go there for, on a Tuesday afternoon after school kind of thing. And that's what we lose. And that's why the National Hockey League was concerned, is that as we lose outdoor skating opportunities, where is not just the participation of elite athletes, but where is the audience base going to be? Because now you're trying to sell the sport to people who've never played it before and never had a chance to skate. So they're really enthusiastic, real boosters. They even got Fox Sports to come out and interview us, which was awesome because the producers for Fox Sports said, just don't say climate change. And so I said, that's okay. Can I say long-term trends in winter weather. Okay. And they said, oh yeah, you can say that which of course
good.
is climate change, right? That's the definition.
Got us there, okay.
Okay, well, I really don't do citizen science work in the way that you do it, but I do capture traditional ecological knowledge in the Arctic. I work with subsistence hunters and gatherers up there and herders, reindeer herders, and their knowledge of the ice and the lack of ice and where it's moving and the thickness is very detailed. So in a way, yes, citizen science can be very, very powerful, especially if you engage those actors that are out there on the front lines. Scientists, we go out every once in a while. Our field season, my field seasons up there are a couple weeks out of the year, but they're out there day after day after day, and they have the traditional knowledge to interpret what they're seeing because their elders have taught them that. So it can be very, very powerful.
Absolutely, all examples of great engagement in science. I know that, Lake Placid, Saranac Lake, and North Country region, we are very proud of our athletes, and many of them start very young, right? And so when we think about, the number of hours, right, that it takes to become an expert in your research, John, I absolutely think that it would very much capture the attention of our community here. Obviously, a lot of our athletes, probably even competing here, probably started out on kids. I also think about sort of an access issue there, right? If you've got a backyard rink, right, you're not having to pay to access an indoor rink. You're not having to sort of drive somewhere. That accessibility piece is really sort of a diversity issue that we can think about is how do we make sure that people have access and those that can pay, right, are going to be more likely in the future than if they've got access to indoor ice to do that than other locations. So something to sort of think about and include. Does anybody from our audience have any questions for us today or online? I've got access to the online chat box also. Oh, looks like we've got one. Great.
John, would you go into you're John, right? Would you go into a bit deeper in the mechanics of positive feedback, how that works?
Oh, the permafrost or just in general?
Well, you were talking about permafrost, so
Yeah.
Maybe some other
Okay, it might be, another example was probably easier to imagine, and that is sea ice in the Arctic. So sea ice is white, especially when it has fresh snow on it, and it's very good at reflecting solar radiation back out to space. In fact, about 70% of the radiation coming into the planet bounces off fresh snow. So it's very good mirror. If that melts, it exposes dark seawater, and that absorbs that radiation, turns it into heat, and that magnifies warming. So if we have less ice, you have more warming, causing less ice, causing more warming. That's the positive feedback. So with each cycle, each year, it gets worse and worse and worse. The same thing with permafrost. Once it starts melting and exposed to the solar radiation, then you have more melting, and there's a lot of carbon in the permafrost, and that comes off as CO2. And if it's covered by water, it comes off as methane. And then all that old ancient carbon gets thrown up into the atmosphere. And there's twice as much carbon in the permafrost than in the atmosphere right now. So it's something to pay attention to.
Is that an irreversible process once it begins?
We don't know. The threshold that I mentioned, 1.5 degrees, is when a lot of the permafrost is expected to start being exposed. And then you would hope that we could get climate change under control, and then it would refreeze. But it all depends on that refreezing in the wintertime. And right now, their winters, especially up in the Alaskan side of the Arctic, are very, very warm. In fact, they don't even have snow now, so they're talking about saving winter as well.
Thank you.
Great question. Yeah, absolutely. I think of that idea of exponential, right, and continuing to sort of worsen the issue. It's sort of we've ignited a problem, and then it creates that problem, makes it even worse when we think about those positive feedback loops. I could also talk about maladaptive climate adaptation strategies, but I'm not sure if that's something we're into. Anybody else have a question?
I have a comment.
Oh, great.
I consider myself a scientist and really appreciate all the data that you have all presented, but I'm not sure anyone of us needs more data to understand that this is a pretty big problem. We just are proving the obvious. However, I think there's a source of data that might be really interesting to all of you, which is from the Nordic skating community. There's a really, really active Nordic skating community in the Northeast with listservs in Maine, New Hampshire, Vermont, and the Adirondacks. And I get multiple emails a day from people scouting ponds and lakes, and including the ice depth and the ice conditions. And the Upper Valley of New Hampshire has been having an amazing year, and there's been a lot of skating at high elevation ponds. The Adirondacks, not so much. But the conditions are also recorded, and I believe they're all recorded on wherever all of the posts are stored. So you could recapture all that data by looking through and seeing what time of year, actual dates and ice thickness for different ponds checked over time. And I'd be happy to share those forums if anyone is interested. And I think also there's a really interesting growing local knowledge about what safe ice is, because nobody wants anyone to go through the ice. And so there's really good shared information about what 2 inches of ice means when it's new and black and hard, and 2 inches of ice when it's gray and full of air. So it's a source of really interesting data and safety information. And the other thing I would add is, throughout the past 3 days, there's been a lot of agreement about climate impacts and loss of snow and shorter seasons, and some implications about mental health. But I got to tell you, as an ice skater, the snow and ice keep me alive. My mental health depends on how I feel when I skate, on some level. And I think that's true for the people who ski and snowboard as well. That athletic, our physical lives and our mental health depend on that way of living in the winter. And I just think that's important.
Yeah, absolutely. Thank you so much for both sharing the resource, and we'll make sure to get that information. But also, yeah, our emotional and physical well-being. And I think Robert also talked about communities, right? And not just our kids playing together, but our communities functioning and living together. It's an important part of how we sort of survive our long, dark winters up here. Absolutely, those recreation opportunities. Anybody else with a question or? Great, we've got one down here in the front. You're doing a great job running around. I've been doing this all day. I've seen this.
And I keep on moving places in the auditorium,
Yeah,
so I'm not
they're
making their life
following
easy. I've actually got two questions. One, which is really out of curiosity, because I actually asked that question to people here, and it's not that scientific, but it was for me to understand, how do you guys know here? I mean, I understand the science, what you mentioned about the thickness of the ice, but how do you inform people when it is safe to get on the frozen lake? Because I know that in places in Europe, for example, in Scandinavia, whenever it's safe to go on the lake or the river or whatever, it's actually published. There's like a statement by the authorities, and that's mainly to avoid having to go fish people on the frozen lakes or ponds. And the other question I had, you showed and you explained, you linked it a lot about people playing hockey in their backyards and everything. How much connection do you have with the sports institutions? For example, I know the NHL does the Winter Classics, and that's probably a great moment to actually showcase ice on a pond. Is there any connection with those sort of institutions to try to promote the importance of the lakes and these sort of practices?
Great. Do we want to tackle that first question first? I don't think we have any sort of alert system here in the Adirondack North Country. I only know this because I took a walk on the ice last week and immediately turned around, my friend and I, as we experienced a bit of a shift and a crack.
Yeah, so there is no formal system to say this lake is safe or this one is not. And I think everyone's concerned about liability from making those determinations or publishing that information. So at the Adirondack Watershed Institute, we just refer people to the New York State Department of Environmental Conservation. I think their recommendation is 4 inches of clear ice as I think what they recommend as being safe. And then there's usually some nice little graphic that says if you're going to bring your snowmobile this much more, your truck this much more, your semi-truck, you need 18 inches or something. So those are out there, but there's no system to notify people. It being a group of scientists that we go out on in conditions that are maybe a little more marginal, and I wouldn't recommend other people going out. I mean, we have float coats and ice picks and all the things to do that safely. The Nordic skating community probably pushes the thickness the most, and is probably most aware of what is safe because they want that thin, hard ice that's making the shooting noises and stuff as they're skating across it. And our concern is that when people see us out on the ice, and we've noticed this, that then other people start coming out on the ice. And so I've been out on Mirror Lake in very marginal conditions, and then watched people from Main Street start walking out onto the lake and want to be like, no, don't come out here. So my general recommendation, is that it's like personal responsibility. You should know how to measure the thickness of the ice, before you venture out onto it, and have systems in place to keep yourself safe. Make sure someone knows you're out there, that you have spikes so you can pull yourself out if you fall in, all of those sorts of things. And I will pass the other question to my colleagues up here.
Sure, thank you. Yeah, so I think with the National Hockey League, they've been very, very active in terms of sustainability for a couple reasons. One, and in a couple different dimensions. One is access to the sport for non-traditional hockey playing communities, i.e. Middle-class Canadians, beyond, expanding that to a larger community. But also I think they're aware for a couple things. One is that they build arenas in the desert and in Florida, and they play professional hockey inside. So they want to see that their sport is making sure it's doing offsetting, making sure it's reducing its carbon impact. Just out of curiosity, I asked what is the biggest source of energy use in an arena in Tampa, Florida, for example. And it's dehumidification. You put 20,000 people inside a hockey rink and they're all breathing heavily. And it is so humid in there, the ice starts to collect water. So that's the greatest energy use. It's not freezing the ice, it's taking water out of the air. But they've been a big supporter over the years. But also we've had some connection with minor hockey coaches who, for the reasons that John was talking about, there are certain skills that you perfect on an outdoor skating rink that you don't perfect on an indoor skating rink. Indoor ice is consistent, smooth, you know what you're getting. Outdoor ice is uneven, and it's typically a smaller space. And so the skills that hockey players learn playing outside are different and better in many ways. That's where Wayne Gretzky perfected all the skills that he was known for. And so the coaching associations in Canada now have outdoor skating drills for amateur coaches and things like that to encourage that. But it is a bit of an uphill battle since right now where I'm from in Southern Ontario, there are no, well, I shouldn't say it, they're starting today. There's a skateable rink in my hometown outside because it went down to minus 11 degrees the other day. But yeah, so this is the challenge we have, is that this is the best opportunity to make good professional athletes and high performance athletes. And it also creates a lifetime pastime. Once you learn how to skate, it's sort of like riding a bicycle. You do that the rest of your life. We're losing that. So yeah, great questions. Thank you.
I have a couple comments on some previous questions, if that's okay.
Absolutely.
Kate, you had mentioned equity. One of the reactions I've been getting to this article is coaches telling me, saying, well, there's some really good NHL players coming out of Florida and California and elsewhere. They get their 10,000 hours indoors. But there's a huge equity problem with that, because indoor ice there especially has to be very expensive. So you're not going to have the access to, say, the low-income skater that wants to do this and has a lot of talent, and then you could sort of help them along. So that's one thing I wanted to mention. But also the mental well-being element about this. I couldn't help but think about this morning of my two sons were playing hockey in front of the Golden Arrow. They were having just a ball playing out there. And I was sitting in our hotel room with my wife, and I told her, I have to go present on how this is going away. They were having the time of their life. So I'm getting choked up here. That's what we're losing. We're going to lose a lot of that. And you can't just make it up with indoor ice.
Yeah, absolutely.
I saw them. I was watching them. Very envious.
Were they good? Yeah, they were good. They were good players. They got potential, maybe. Yeah.
They were just throwing the puck around.
Just throwing the puck around, having a good time. Excellent. All right. Does anybody else have a question? Oh, ready to go. She's already got the mic. We're ready. Excellent.
My name is Georgia Jones, and I live in Lake Placid. I've been here. My question is very specific to this place. We advertise ourselves as the sports capital of the world, winter sports, and we have had all kinds of events here. I have seen that a lot of outreach to other organizations and to our community have been made to, and Brendan can attest to this, that we are making real progress in getting salt out of Mirror Lake. And it's a lot of it because we've aggravated people enough to pay attention to it. I would like to have some list of what we could do in Lake Placid to make us stand out with the rest of this country as being an example of what can be done to combat this, because we are going to lose skating, as you talked about, but it rained on Friday morning or Monday morning when we were supposed to have an opening race at Whiteface. Our ski jumps are almost all man-made snow and plastic. And I think we could be an example to the rest of the world if we could get it out there. And I want to know how we're going to do that.
Yeah, Brendan's on a
plan.
tremendous amount of work on this. Yeah, absolutely. And I think I saw Dan Kelting in the audience also earlier. But did you want to?
Geez, I don't know that I have the answer from the climate perspective. There's been so many great things shared as part of this conference and elsewhere, and all the progress that Lake Placid is sort of making on that, to address those issues. So I think part of it's a matter of just shining the light on those, and hopefully some of that's happened, here with this conference already. In terms of the road salt thing, I think is maybe a great reminder of the importance of all of us engaging with our government to make these changes. And so the beautiful thing about road salt is it's a problem that we created on our own backyard. So we literally just need to talk to our local government and to some extent the state government, and we can solve that problem, and we're headed in that path. I think it's the same thing for climate change. It's just more governments and bigger scales that we need to do it on. So I would just encourage, everyone to, to think about ways that you can be that squeaky wheel, because I think it was a lot of squeaky wheels here in Lake Placid on the road salt issue. Keep talking to your local government representatives, keep the conversation going, keep the light on this issue. And I think, we will get there. That's sort of the extent, I guess, of my commentary, but I'm happy to turn it over to others.
I don't have anything specific. I just want to echo what Bill McKibben said the other night. He said that he doesn't know if this civilization is going to continue. He said, though, that if we do nothing, then we know it won't continue. We know that it will be lost. So you have to do something, because if you don't do something, then you know it's going to be lost. Another climate activist named Tim DeChristopher said it even better, I think, which is very hard to do with Bill McKibben, but he said that this civilization, he said it flatly, is over. It's either climate change is going to force it under, or we're going to change it so that we can adapt to the conditions that are coming. So it's worse to do nothing. You have to do something within your own power for everyone to save winter.
So I'm just going to end on maybe I've made it my professional career to work with communities and people, and particularly college students, to make changes, to build climate action plans. One of the things that we like to talk about is that sphere of influence piece. You have your personal home, right? There is your larger community. Then you can think about this on sort of a federal, a governmental level, and an intergovernmental level. And we can work together to implement change on all of those levels. Here in Lake Placid and also in Saranac Lake, the DEC has a great program called Climate Smart Communities Program. I think you heard a little bit about this earlier. This is a way where communities work with village offices. We do climate action planning on village levels. Here in Lake Placid, you have a very active group that's also been working with the USGS Lead for Communities program. I'm on the committee in Saranac Lake. So whether you're looking at your household emission levels reduction or a community level, you can and we will continue to implement change on this, but it is a very real threat, and I absolutely understand that concern moving forward as we see some of these implications. Well, I think we're almost just about time. Does anybody have any sort of last questions here? No, well, I just want to, again, thank all three of you for coming out today. It's been a wonderful conference. Carlin and the team, thank you so much for organizing. This has been a tremendous 3 days for us to be a part of. And thank you all for coming out on a lovely Sunday afternoon. And I believe up next, we actually have we actually have one of my favorite local authors of The Dirty Life. She's going to be doing a really wonderful talk on food and local food and the importance for athletes and nutrition. So that's coming up next. Thanks so much.
All right. Let's give this panel a bigger round of applause than that. Come on. Thank you guys so much. Thank you. Wonderful.